Ladies and gentlemen, thank you for standing by. Welcome to the OpenStack Block Storage Design Considerations webinar. During the presentation, all participants will be in a listen-only mode. If you would like to ask a question during the presentation, please use the chat feature located in the lower left corner of your screen. If you need to reach an operator at any time, please press *0. As a reminder, this conference is being recorded Tuesday, April 29th, 2014. I will now turn the conference over to Aaron Delp. Please go ahead.
Hello, everybody. Good morning, good afternoon, good evening, depending on where you are. I'm going to take a little time today to talk about OpenStack block storage design and the considerations that go with that. I'm, of course, Aaron Delp, and I'm joined by two other great speakers today. First of all, we have John Griffith. John is actually the PTL or project lead for the Cinder block storage project, and he is also a solutions architect at SolidFire. And then we also have Kenneth Hoy. Kenneth is a technology evangelist at Rackspace and is also very active in blogging specifically about block storage and Cinder within the OpenStack community. I want to talk a little bit about agenda very briefly. Let's set some expectations. As a reminder, as the operator mentioned earlier, we will be doing Q&A. If you have a question at any time during this presentation, go ahead and pop it in the chat in the corner, and we will be monitoring all of that, and we will actually be having a Q&A discussion at the end of this. And we'll be talking for probably about 35 to 40 minutes, so we'll have plenty of time at the end of this for question and answer. And also, in addition to that, if you find this valuable and you want to either listen again later on or pass this along to somebody else, this will be recorded and available for replay after this as well. And with that, let's jump in. Start a little bit with what is cloud computing. This isn't just a collection of virtual machines. For us, this is all about how do you abstract and automate those static resources, if you will. And actually, I think this picture and this diagram here says this a little better. What we have at the bottom is really compute, storage, virtualization, and networking, providing resources out. And in an older fashion, if you will, they were providing those resources directly to those applications and the users or administrators. But what we're actually doing here is putting an abstraction layer in place so that we can create dynamic pools of resources as opposed to static resources that we've had in the past. And in addition to that creation of those dynamic pools, we're able to automate that delivery so that we can connect our applications via APIs or really serve our users and our administrations and our lines of business much faster. And if I look for a second, take a step back and say OpenStack is, right? What I want to answer on this particular slide is really more of the how and what is OpenStack. So what we're looking at here is, again, an abstraction layer from physical and virtualized resources, but not just hypervisors. Bare metal, storage, networking, load balancers, databases, whatever kind of requirements we have on our infrastructure today, we want to abstract that away and provide that to our users and the administrators in a very easy and open and flexible way through REST-based APIs. So the idea behind this is providing self-service and delivery of dynamic resource pools. And if I look at the next slide, this really goes more into the why. Why would I want to do this? Why do I want to move beyond just standard virtualization or offering those static resources? For me, this is about Jevons paradox. And if you're not familiar with Jevons paradox, as technology progresses, there's an increase in efficiency in an organization, which in turn increases that rate of consumption and increases the utilization of that infrastructure. So that's a really fancy way to say we can go faster. And in addition to going faster and serving the needs of our users faster, we're also able to focus on higher level tasks that provide much greater value to an organization. We don't necessarily need to be caught up in the day-to-day administration of things. Through automation and provisioning, we're able to do the tasks in our organization that really move the ball forward and achieve our goals in a much greater way. And once we get the how, what, and why kind of out of the way, we start to look at use cases. Cloud computing really was born out of some basic needs within infrastructure in the IT industry, specifically around, let's start with test and development. Test and development is all about taking those internal resources that were for Q&A testing or other things such as that, and providing those test and dev resources in a way that we can dynamically create those pools, provide them to our test and dev organizations, and then take them back when we're done. And then from that kind of leads over into production and enterprise IT in a slightly different way. If we talk about enterprise IT and production, a lot of times we're talking about DevOps and continuous integration. DevOps and continuous integration are, again, that ability to go faster within an organization. And instead of traditional kind of waterfall development models like we've had in the past, how do we make small incremental changes to our production environments but do them in a very safe and efficient way? And then those last three bullets, I actually combine those all into one. Of what we're really trying to do here is take resources and match them to those infrastructure types. OpenStack is really great at providing those resources, especially around database and web services, in a very fast and efficient fashion. Now, no talk of OpenStack as a project. We can't really talk about that without talking about the community. OpenStack is, of course, open source, and so if we look at the open source project and the OpenStack Foundation, very significant momentum over the last couple of years. A community that has now grown to over 15,000 members and over 300 companies participating in a very short amount of time. And really one of the best ways to judge an open source project is really behind the momentum in the community. And OpenStack is just continuing to grow by leaps and bounds. But if we also go back to contributors and early adopters, this is if you follow the OpenStack community, you're probably familiar with a lot of these logos and you're probably familiar with a lot of these use cases. But if we say, for instance, Rackspace, of course, really kind of launched all of this in cooperation with NASA and really created the first initial couple of projects here. And then from there, we were able to take the Rackspace and NASA collaboration and really start to extend that out into these other organizations and really create a very solid foundation of use cases and customers within the industry. And that finally leads into this vendor ecosystem. Again, mentioning that over 300 companies. This is, of course, just a small sampling of them, but it goes back to what I was saying earlier. On that base layer along the bottom, compute, networking, block storage, and object storage, very large number of vendors and very, very large number of big-name vendors who are very critical to the success of OpenStack going forward. And then above that is really the operations and abstraction layer we've been talking about so much through the various OpenStack distributions offered on the right-hand side, or on the left-hand side, tools and companies that are out there of how do I operate this, not just day one, but how do I operate this environment a year from now, 2 years from now? How do I do configuration management, capacity planning or monitoring? And lastly, as I go to that application layer on the very top, we have a very active ecosystem of vendors looking to participate and actually tie their applications or their PaaS, Platform as a Service environments, very tightly into the OpenStack ecosystem. And with that, that's a very quick introduction of where we are and where we're going. And so with that, what I'd like to do is turn it over to Kenneth Hoy with Rackspace. And Kenneth is going to talk a little bit about OpenStack and storage in general, and then we'll be flipping it over to John near the end to talk about Cinder in particular. So Ken, if you don't mind, take it away.
Sure, thanks, Aaron. Appreciate that. Welcome everyone to this webinar. I wanted to set the context for OpenStack block storage in the context of explaining that there are two current storage projects within OpenStack itself. One is the Cinder block storage service, which we'll be talking about today, and the other is the Swift object storage project. So we won't be spending much time talking about Swift at all, other than to say that it is a service that is designed specifically for unstructured data and often used for backups and as a repository for VM images as well as snapshots. But what we really want to focus on is the block storage project known as Cinder, which provides a very traditional block storage for structured data. Typically, you would find that either as in previous times as an attached storage or using an enterprise storage array. And it's meant for workloads such as databases, things that are very bursty, have a lot of random rewrite IOs and very structured type of data. So what is Cinder actually? So Cinder, again, is a way to provide block storage services to cloud instances that are running on your Nova compute nodes. So this is a way to provide persistent storage. Prior to Nova, any block storage that came with a cloud instance was not persistent. In other words, if that VM was later terminated, all the data on those, all the data in that storage was purged. But by providing Cinder, we're able to provide a way where the storage will stay, the data won't be purged when the instance is deleted, and instead you can actually take that block storage and plug it into another cloud instance. Think of it much as a USB drive that you can plug into your laptop, and then you can unplug it and plug it into another laptop for use. So that's the primary use case for using OpenStack Cinder. And the service itself basically allows you to create, attach, and detach volumes to those instances using either the OpenStack dashboard or via CLI or even the application API. And these are some of the features of Cinder. Particularly, you'll see that besides the basic creation and deletion of volumes, you have things like being able to assign special customization specs, and also being able to take snapshots and clones that have been used to restore data at a later time. I want to talk a little bit about how Cinder is actually deployed in an OpenStack environment. I'm going to focus my attention on using commodity storage. And when I say commodity storage, I typically mean a off-the-shelf server, maybe a Dell server or an HP server with direct attach storage or maybe a SCSI array behind it. And then John later will talk a bit about how Cinder can be used with enterprise storage components. I'll have a diagram later to show you all the different components. But note that in a commodity Cinder environment, there are several components that need to be in place. First, you notice there is a controller node. So a controller node in an OpenStack environment is basically the brains of the operation. It holds all the metadata for your OpenStack cloud platform and has all the control points that you interact with in order to provision Cinder storage. And on that controller node, and you'll see later if you want to pair those, there are a couple of services that run. One of them is a Cinder API. That is, again, the endpoint for which you would interact with OpenStack to provision Cinder block storage. And then there's also a schedule service, which is used to assign storage, assign Cinder volumes if you have multiple Cinder nodes serving out those block storage. Note that one of the requirements currently today with Cinder is the use of a storage network, particularly Ethernet network that would be used for iSCSI. So in the newest release of OpenStack, Fiber Channel, its support came into being, but because due to the maturity of the state of iSCSI within the OpenStack Cinder project. Rackspace uses that as our recommended storage protocol. And obviously, as with any iSCSI network, we recommend using redundant 10 gig connections. Another component of Cinder is a Cinder volume service that sits on what we will call a Cinder node. And these are the recommended requirements. Note that the first two are specific for Cinder, whether you're using an enterprise storage array or commodity server as your storage backend. And then the last two, the physical drives and array protection, are requirements if you specifically are using a commodity server as your storage backend. So let's put that together a little bit in this diagram, which is using a Rackspace private cloud powered by OpenStack as the reference architecture. You see here, first of all, the iSCSI network on the bottom that I mentioned, which all the compute nodes and the Cinder node has to have access to. In addition, you'll see our two controller nodes, which will run both the Cinder API service and the Cinder scheduler. So when you are provisioning a block storage with an OpenStack, you would be actually connecting to these one or two of these controller nodes. What I want you to note here is that on the Cinder node on your right, that is again a commodity server, a Dell, HP, or even a Open Compute server running some type of storage. And we don't really care what storage it is. It can be SSD, it can be SAS, it can be SATA drives. As long as the Cinder node can talk to those storage using a logical value manager, we can serve out storage. And that storage is connected, then served out through the Cinder node to the hypervisor, the compute nodes that you see here in the middle, which house your cloud instances, and those cloud instances are able to connect to those provisioned storage volumes. Here is just for a point of comparison, is how it would look using an enterprise storage array such as a SolidFire. And John will review this diagram during his part of this session. So a couple of advantages of using a commodity storage system as a server with connected attached storage is obviously the low initial cost. So if you have a small proof of concept environment where maybe you're using no more than 1 or 2 terabytes of storage, a server is acting as essentially a storage array. It offers a low cost entry point. Also, there's very little change, obviously, in your procurement process, since you will be procuring basically another server to be used as your storage backend. And then obviously the infrastructure now, storage knowledge is very, very minimal. Again, if you have a Linux admin who knows how to set up a logical volume on a Linux server, they are able to manage a Cinder storage array using a commodity backend. As you would expect, along with those advantages, there are some limitations to using a commodity backend. First and foremost is the fact that a Cinder node volume server is not redundant. So if in an environment where you have some number of storage attached to your VMs, if the supporting Cinder node that's serving out those volumes were to go down for some reason, those storage volumes become unaccessible by your cloud instances. Also, a commodity storage has a limited number of capacity scaling, and I have a diagram to show what I mean by that later. And then lastly, there's obviously some value-added services that existing enterprise array customers may be used to, such as QoS and replication, that is not currently part of the Cinder service using commodity storage. So talk about the first point, the lack of redundancy. If you look here, we have another reference architecture using a Rackspace private cloud with this time multiple Cinder volumes. And what you'll note here is each Cinder node is actually an independent system. They're not connected to each other in any way, so that if one Cinder node fails, there's no failover mechanism that occurs. In effect, all the volumes behind that array is now inaccessible until you repair that Cinder node. And then talking about capacity. So in a Rackspace private cloud, a typical Cinder node is a Dell server with 8 600 gig 15K SAS in a RAID 10 configuration. That delivers approximately 2.3 usable terabytes. Now you can swap those out. You could use more drives. You can use drives with larger capacity. We typically use this configuration because most of our Cinder customers are using Cinder for MySQL or Postgres type databases, which typically need the performance requirements of a RAID 10 config using 15K SAS drive. But using that standard 600 gig drive as an example, if I had a MySQL database environment that required 8 terabytes, I would need 4 of those nodes, since each one's independent, in order to meet that capacity requirement. Over time, if you have an environment that grows to several hundred terabytes, you can see the management overhead that comes with having that many Cinder nodes can be fairly high. So for that reason, at Rackspace, we've chosen to partner with vendors like SolidFire to enable enterprise storage arrays into our Rackspace private cloud solution. And at this point, I'm going to turn this session over to John Griffith from SolidFire to talk a bit more about Cinder with enterprise storage subsystems. John?
Great, thanks, Ken. So hi, everybody. As you heard, my name is John Griffith. I work at SolidFire. I also work on the Cinder project on the PTL currently. So Ken kind of touched on the existing, like the commodity picture for Cinder and stuff like that. So inside of Cinder, we actually have a reference implementation that is built on your commodity storage. It just uses LVM and does some abstractions and some things on top of that. The thing that's really unique and interesting about Cinder, though, is it uses a plug-in model for just about any backend that you want to plug into it. So it provides a nice abstraction on top of that. And what it does is provides you a seamless, kind of a seamless interface that anybody can use any backend that they want, that they have a driver implemented for. So I'm going to talk a bit about third-party vendors, enterprise storage vendors, and things like that, and kind of focus most of my talk on that. But keep in mind, the whole idea is you can plug in various storage products behind Cinder. Not only that, you can have multiple backends plugged in as well. So because of that plug-in model, you're not limited to just one implementation. You can have a EMC array, a SolidFire appliance, a NetApp, and an LVM or a commodity storage implementation if you want, all running in the same Cinder cloud or same OpenStack cloud, all managed by the same Cinder APIs, the same Cinder manager, and everything else. And the idea is, from the end user's perspective, the end user doesn't need to have any knowledge of what those different backends are. You can expose that if you want, but there's really no need to. The API calls should all behave the same on all of those backends. One of the things that gives us is a lot of flexibility in terms of scaling, growth, elasticity in our deployment. So what we can do is we now have the ability to do things like bring in a new backend or upgrade a backend storage device that you might be using and stuff like that, or even take a backend out. And we can do all of this without impacting your end users, so they can still keep utilizing the cloud, and they won't see any of these changes. So as you get close to capacity, for example, on your first OpenStack deployment, you look at your block storage and you determine that, hey, I'm at 70% capacity, it's time to get some more storage in here. You just add more storage. You don't have to take users offline. You don't have to point them to a new storage device or anything like that. It's just added to the pool and utilized. So, Ken talked about some of the advantages of commodity storage, and I want to talk a little bit about some of the advantages that you get with enterprise storage. So the thing about enterprise storage in most cases is, somebody else has done a lot of the tinkering and working and building and stuff like that for you. So typically what that results in is simplified scaling. So what I mean by that is the ability to actually, increase the size of your deployment, like I mentioned before. Ken pointed out with LVM, you can definitely, with commodity storage, you can definitely go ahead and add more nodes and continue to grow and things like that without any problem. However, it does get very difficult to manage over time. So after a while, you end up with, 50 or 60 nodes sitting back there that you're trying to manage and maintain and keep an eye on. So use some products from enterprise vendors, and they allow you to do things like scale out horizontally and things like that. So that makes a big difference. The biggest one really, though, is high availability. One of the things that's lacking in the existing reference implementation, and one of the things that's really hard to do with commodity storage, is to have a good HA solution. That's sort of table stakes for most enterprise vendors these days. So that's something that's pretty much assumed and pretty much required. The other thing that's kind of interesting to think about from the enterprise side of things and going to a vendor inside of OpenStack, one of the things that's kind of nice is, depending on the vendor and if you choose the right vendor and the right product, it's actually tested and supported by somebody else. So you don't have to not only build the storage system yourself and test it and maintain it and everything else, but you've also got somebody that has professional testers, professional engineers, and stuff like that. That is their job, and that's what they're focused on. So they're doing that piece of the work for you. Granted, nothing is perfect. Nobody's ever perfect, and everything isn't always covered. There can always be problems and stuff. But that is a sizable chunk of investment and a sizable chunk of resources that you get to take off of your plate that somebody else has already done for you. The other thing about going down the enterprise road is, on the Cinder side, there's a common API, and the idea is everybody, every backend that's implemented, including commodity storage, LVM, anything you build, it's expected that it will implement every function of the core API. But the thing is with things like enterprise storage and third-party vendors and those backends, they have advanced features, more enhanced features that only they can do. And Cinder does offer a mechanism for you to expose those features if you want. So that's something to always consider. You can always use things like extensions or special implementations through volume types and things like that to go ahead and deliver some extra things, whether it be quality of service or replication or things like that. And then, of course, one of the biggest and most obvious things is, especially as the data centers these days are going through this transformation and we're heading into the cloud and we're heading into OpenStack. Well, you've already got a data center. You've already got a bunch of equipment and everything. You're not going to want to throw it away, right? So the idea is you can repurpose some of your existing equipment if you want to build your OpenStack deployment. And that's a big win for a lot of people. So kind of talk about some considerations on what to pick, right? And what do you want to do and how are you going to do this in the future? How are you going to deploy OpenStack? And what should you use for your Cinder storage? So there's some key items that I put up here that I recommend everybody look at and pay a lot of attention to because they're really important. You want to look at things like the level of integration and support with OpenStack. And what I mean by that is not only, does this vendor have a driver? Okay, so there's a lot of people that have drivers for OpenStack these days because it's a popular thing, and so it's it's kind of a checkbox on a lot of marketing sheets. But what's really important there is to look and see, do they actually have experience with OpenStack? Are they actually involved with OpenStack on a daily basis so that they really understand how their product needs to interact, how it needs to behave, what the demand on it's going to be, and what the requirements are. If you pay attention to OpenStack and you look at the community and how fast it moves and things like that, you'll understand very quickly that it's an extremely fast-moving target. And if you're not on top of it and you're not participating on a regular basis, you're going to get left behind. And what you'll end up with is a device driver that quite frankly doesn't work. And on top of that, there's folks that have drivers outside of Tree That's always a bad idea in my opinion. You should always look for somebody that has a Cinder driver or an OpenStack driver that is actually part of the OpenStack core code. That's a critical piece because if it's not, that means nobody else is looking at it, nobody else is testing it. You know, OpenStack has an incredible CI and an incredible process in terms of reviews and testing and unit tests and everything else. So you definitely want to get something that takes advantage of that. The other thing to keep in mind is flexible scalability. The thing about clouds, and the whole reason you build clouds, is because they're elastic and they're constantly changing. You want to be able to grow, maybe shrink, you know, and just dynamically change. So you want to make sure you pick a product or pick a device that allows you to make those changes. Granted, like I said before, you can just rely on OpenStack and rely on Cinder to go ahead and do that by adding more devices and things like that. But even better, if you can find a back-end device that actually lets you scale and dynamically change, that's just going to be a win for you. The other thing to look at is the APIs and you know, how they're set up and things like that, and how much you can automate. The thing about OpenStack to keep in mind is it's an incredible orchestration layer. It's a great building block. But the thing is, a lot of people like to go ahead and customize things after they deploy it. So if you use a backend that actually has a well-designed, easy-to-use API, that's going to make things much, much better for you. And then even if you're not in the customization category and you don't want to do anything like that, the other thing to keep in mind is the cleaner the API is, the better designed it is, the easier it is for whoever it is maintaining that driver inside of the OpenStack code, the easier it is for them to keep it up to date and keep it running properly and keep things in check. So those are important things to consider. Of course, you know, back to the things we talked about, HA and things like that, you definitely want to make sure that you have something that is going to provide you increased reliability, good uptime. You know, everything in the block storage industry is based on, you know, keeping your data. You don't want to lose that data. So, and then the final point on here I talk about is performance. Performance is an interesting thing to talk about because a lot of people, you know, the first thought is, oh, I want something that's screaming fast. And everybody wants faster, everybody wants better. But the reality is you want to look at that, and what's really important is I want something that's consistent. So I want something that, you know, especially in a cloud environment, if I have 100 volumes that are in use, and all of a sudden, you know, one of them starts receiving an incredibly heavy amount of I/O traffic, you don't want that to impact the other volumes that are in that cloud. You don't want those users to end up losing IOPS, losing I/O, because it's all being sucked up by somebody else. So that's a really big deal, and it's something to keep in mind as well. So a little bit about the SolidFire appliance. So the whole idea behind SolidFire is, you know, we designed a scale-out block storage system, and we really designed it specifically for massive scale deployments, you know, particularly OpenStack. The whole initial thought process for everything was about cloud platforms, whether it be OpenStack or maybe some others. So it was really purpose-built for OpenStack. Our founder came out of Rackspace when he started this, so that was definitely something that was in his mind the whole time. The thing is, you know, the reason I point this out is the requirements and the demands that are placed on a device in a cloud environment are significantly different than what they used to be. You know, it used to be you'd get a certain array of whatever type, and that would be set up, and hey, this is going to be assigned to our database. And then you get another one, and hey, this is going to be designed and set up specifically for our Exchange servers. You know, whatever the case may be, on and on. The idea with cloud is you're going to put these devices in, and you want them to be able to be used with anything. So whether it be test dev, whether it be Exchange servers, web servers, whatever it may be, you want them to be able to run any workload that you throw at them. So those are some of the things that we definitely looked at from the SolidFire perspective, and we implement and we really focus on really hard. The other thing is multi-tenancy. I've talked to some people, and they don't really see the correlation in an enterprise environment of what multi-tenancy is, how that really relates. But it kind of goes back to what I was just talking about in terms of different workloads and things like that. You're going to have multiple use cases and multiple workloads all running on the same device. And the idea is, by keeping some sort of separation and some sort of multi-tenancy inside of there, it gives you an administrative advantage. So for example, I can go through and I can look at easily inside of the SolidFire cluster, I can look at everything that user, Joe Smith is doing. I can look at all of his activity, look at all of his volumes, and I actually have all those separated. And the other thing is user Joe Smith, because we have multi-tenancy, can't access the data that's used by Janet Jones, for example. So multi-tenancy is an important thing, and I think it's extremely important in cloud environments. The other thing that we do is we definitely focus on linear and non-disruptive performance and capacity growth. So that's kind of a marketing tagline, right? But the whole idea there is to focus really hard on not only the horizontal scaling piece, but also on providing consistent performance and capacity. And the way a lot of people give you performance, and especially consistent performance, is they underutilize their capacity. So what they'll do is they'll only utilize 40%, 50% of their array. With us, that's not the case. With us, you get to use all of the capacity of the product. So that makes a huge difference. And then, of course, I already talked about automation. Automation was built into the product from the ground up. So that's part of our architecture. So we put that in. Our API is core to the product as well. It's not an afterthought. It's not something that we tagged on afterwards. So it's built in from the ground up. The whole idea there is anything that you can do on the cluster, you can do through our API. And then, we keep going back, once again, HA and fault tolerance. Those are just, you can't stress those enough. So, one of the things I talked about was consistent performance. And so this particular piece is quality of service. This is kind of one of the big differentiators for us. So the idea for us is we focus really hard on allowing you to actually dial in on an IOPS basis, volume per volume, what sort of performance you want to see. And so we'll let you control that, and we will guarantee minimum values. So that's how we deal with things like consistency, and that's how we can do things like I said about serving multiple tenants and multiple use cases all on the same device. Of course, we have the ability to do snapshots, clones, all those sorts of things. And then one of the big use cases in our example is bootable volumes. So Ken talked about the traditional use case of ephemeral instances. You boot them up, do your thing, and everything, and you tear them down, and they go away, and the data goes away. So Cinder and the block storage inside of OpenStack, back when it was no volumes, introduced the idea of being able to attach persistent data, similar to a USB thumb drive, as Ken explained. I love that example. And that's great. But the other thing that we can do now is we can actually use that persistent storage as our bootable volume, as our bootable medium as well. So, spin up an instance on a SolidFire volume, for example, make all your changes, edits, or whatever, and if something does go wrong, something goes away, you still have that data. You still have that. You can bring that all back easily enough. So, the integration with Cinder, I work on Cinder, full time. So, try to make it as simple and clean as possible. Currently, right now, it's 3 lines in the cinder.conf file is all you need to add. You don't need to download any libraries or any special tools or anything like that. Just make 3 entries and you're good to go. So Ken showed this slide earlier, and I wanted to kind of show it again with an alternative in there, right? And what we should have done is Actually, I should have made another one even with multiple back-end devices, but you should be able to get the idea here. So the point here is everything behaves pretty much the same, right? So the idea is that piece where I have SolidFire, that truly is just a plugin. So you're just plugging in a different back-end device. So that's the whole idea. With the enterprise devices, and with SolidFire in particular, you can, for example, start out with 5 nodes, and as you expand, you can just add more nodes to it and just grow that cluster, all while it's online, all without taking anything down, and all seamless to your end users. So that's a really big consideration from the enterprise side as well. So with that, I think at this point I'm going to turn it back over to Aaron and let him kind of talk a little more about some of the final thoughts here and wrap up for us.
Yeah, absolutely. Thank you, John. What I'll go ahead and do, first of all, is just kind of advance the slides one more to really some resources and a little more information about it. And then we'll kind of jump right into the questions. Again, reminder, we've got actually a ton of questions lined up, so thank you, everyone. But if you have an additional question, throw it in the chat, and we'll get to as many as we can here today. First of all, the number one, I'm kind of lumping a couple questions together. In this presentation, you talked specifically about iSCSI. How is fiber channel handled in a Cinder world, if at all?
John, do
you want to take that one, or Ken?
Yeah, sorry, I was on mute. So I gave a great answer, and if you didn't catch it, sorry. So the fiber channel is fairly new. Ken mentioned iSCSI is definitely the traditional standard. It's been around the longest. It's been used the most. But that is changing, and fiber channel is coming on board. Especially on the enterprise side, you have a lot of people that already have fiber channel, so it's obvious that they're going to want to use that. And, we already mentioned the whole repurposing equipment, redeploying existing resources, and stuff like that. So currently there is fiber channel support inside of OpenStack and inside of Cinder. The caveat to that until recently was there was no zone management support. So basically the way it worked up until the Icehouse release was everything was just automatically put into one big zone. All the compute nodes had access, all of the Cinder nodes had access, and that's how we dealt with it. The next steps, which have already begun, are to actually do fiber channel zone management. So there is a fiber channel zone management plugin module. There's an object that you can use there. So that work is coming along. It is still really immature, and it has a ways to go, but it is getting there. And I think, throughout the Juno release, I think a lot of progress will be made again, and I think it'll just continue to get better. So there will be good options there.
All right, thank you very much. The next one, I'm going to answer this one just because it's been asked a couple times, and I did put it in chat before. There will be a copy of the slides given after this, as well as a replay link for this as well. So everyone will get a copy of these slides. Next question is there a way currently to ensure that the network is following best practices for iSCSI networks?
So I can handle that. So at this moment, there's no way to do that within Cinder. The idea is that that iSCSI network infrastructure is laid out by kind of before you even lay down OpenStack. So what you should do for anyone who's deploying Cinder is to follow the best practices that are laid out either by, say, if you're using Rackspace Private Cloud by the Rackspace team, or if you're using an enterprise storage array from SolidFire, then you should follow the best practices that are coming out of SolidFire.
All right. Next one, again, fiber channel related question again. And it maybe have already been covered, John. I just want to make sure. Given that the cloud architecture is multi-node typically, does this mean iSCSI is always being used even when your Cinder volume node is fiber channel or SAN?
So no, if you are using Fiber Channel, it will use that Fiber Channel connector instead. So we have an abstraction inside of Cinder, and what it does is basically it takes your backend device, it figures out what type of, we call it a connector, figures out what connector it needs, whether that's iSCSI or Fiber Channel, and it embeds that information into the object when it passes it to the compute node. So then the compute node can look at that and say, hey, I need an iSCSI connection, or I need a Fiber Channel connection, or whatever. So they can coexist in the same deployment.
Yeah, and actually in certain cases, depending on the vendor, you could actually take an NFS file system and read it as an iSCSI value in Cinder, interestingly enough.
All right. Okay, when you say true QoS level on a per volume basis, volume is one LUN on a SolidFire, or volume in OpenStack, a volume in OpenStack potentially spans multiple LUNs on storage. So I apologize if I kind of butchered the asking of that question, but I think what they're basically saying is it is a one-to-one tie-in of per volume to OpenStack.
Yeah. So the thing about SolidFire is it's a little bit different. It's not a RAID array. It is a clustered storage appliance. So we don't have LUNs. We don't have the concept of LUNs. When you create a volume, for example, when you create a volume inside of OpenStack, it is a volume object on the SolidFire cluster as well. So that's why we're able to do things like QoS level on a per volume basis. Folks that try and do that, when they're splitting things across different LUNs and things like that, that's a little more difficult and doesn't usually work out very well. So hopefully that helps. I'm not sure if that was on target or not, but.
Nope, I think that's great.
Actually, sorry, Aaron. Let me
go ahead.
And this may help clear up some confusion. Is that keep in mind that Cinder itself as a block storage service is actually abstracting the underlying storage from the cloud instances /VM. So rather it's using QoS spanning multiple types of volumes, rather it's using iSCSI or Fiber Channel backend. From the perspective of the cloud instances that are attaching to that Cinder volume, it's just a SCSI. It's just a hard disk, or in this case, more like a USB drive. So it isn't even aware of what's going on underneath the covers.
All right, cool. What if there is a storage failure, or I want to move to new storage? Can I move my data to new storage without downtime?
So that's actually a really good question, and the answer, unfortunately, is kind of it depends. So there are things that are in place right now to do migration, so you can migrate from one device to another. Again, that's one of those newer things, and I think it's got a ways to go in terms of maturity and stuff like that. The downtime, there is some downtime associated with that in terms of that volume is not usable. So you can't have that volume online and actively using it while you do that. There are, some implementations will do things like do a snapshot and then do the backup, so the interruption is really short or maybe almost seamless. But it's not. Again, it's one of those things that's new. So there's some work to be done there, but that is something that we're working on and something that is going to continue to get better and see improvements as OpenStack goes along.
All right. We have more questions coming in. Let's see. I'm just looking for. Okay. This one is really kind of a question for really both of you. Kind of a generic one of what do you mean by automation, and then probably, I guess, put that in, what do you mean by automation, and how do you utilize automation within both OpenStack and specifically in the SolidFire arrays?
Okay, John,
Yeah.
I'll take the OpenStack portion, and you can talk about SolidFire.
Okay, go ahead.
Yeah, so when we talk about automation, what primarily makes that happen is the fact that all the services within OpenStack, including Cinder, all those functionalities fully exposed through APIs. So a programmer writing an application that's leveraging Cinder can actually write to those APIs to basically enable Cinder. So an example would be having a setup where you may have an application that's using some kind of Cinder block storage for MySQL backend, and you are doing some type of auto scaling where you need to create new instances on the fly as performance requirements dictate, and you want to automate that instead of having to go through the manual process. You could write to the OpenStack APIs to spin up new compute instances, the cloud instances, and then also use that to leverage the Cinder APIs so that you're creating these Cinder volumes and attaching them to the new cloud instances that's needed. So that's an example of using enabling automation to occur by using these OpenStack APIs.
Yeah. So I think that's a pretty great example, and a little more detail or an example use case. Something that I have is I have scripts that do things like deploy OpenStack clouds in my lab. So not only can I automate everything that I do inside of OpenStack, including its deployment and spinning up instances and running workloads and everything else, creating users, so on and so forth, but I can also do things like automate going out to my storage device and configuring it and making changes to it as well. So all of that stuff is automated. So the whole point of that is there doesn't have to be a user sitting there at a web console or at a command line or something like that, typing every single change, every single command in. The whole idea is you invest in automation, you invest in writing tools to do things, and you let those tools do those things on their own. The reason that's really important is when you talk about cloud and when you talk about OpenStack, we're talking about massive scale. We're talking about hundreds, maybe thousands of compute instances, for example. Trying to manage those and deal with those all by hand as an admin is not something that you want to do, right? So you want to automate all those things and have all that work for you through tools.
Okay. Can you, and if so, how, do you replicate or back up a Cinder volume to a Swift object volume?
Excellent question, and I can't believe I didn't cover that. So Cinder actually has a backup service inside of it, and that backup service interfaces with Swift or S3 compatible object stores. So currently today, you can actually, just using Cinder, if you've turned on the service and you have a S3 compatible backend, you can go ahead and tell it to do a backup of your volume to that object store. So there's, again, it's one of those things, we're not doing differential backups and stuff like that yet. We're not that complex. Right now it's a dump of the block storage volume over to Swift, and then of course you can restore that and create a new volume from it. So that's where we're at.
All right. Question related to hotspots on an array. How do you deal with hotspots, and can you pre-schedule times to move hotspots, or how does that work within both OpenStack and SolidFire solutions?
So I'll take that unless you wanted to comment on something. So from Cinder's perspective, the thing to keep in mind is, I'm assuming you're referring to hotspots like LUNs on an array, right? The traditional issue that we have there. So OpenStack in Cinder doesn't necessarily have that knowledge or that information. That's kind of up to the vendor to figure out how to manage their storage, whether it be in their driver or whatever, or in their storage product itself. What Cinder does do and does allow for you, however, is if you have multiple backends, it will go ahead and the scheduler will use weights and capacities and things like that to figure out where to place objects. So there's a number of ways you can do it, and you can tune this and change it to however you want. We call them scheduling filters, and you can filter on things like how much capacity, how much utilization, what the performance levels are, what features the thing has, like is it thin provisioning, so on and so forth. SolidFire, for example, we don't have that problem. We don't have we don't have this concept of hotspots or anything like that because we are a distributed storage appliance. So every block of data is distributed across the entire cluster. There's no central node. There's no central disk. None of that. So so it's kind of a different model.
And to add to that a little bit, talking about the filter schedule, one thing to keep in mind is, unless that's changed in Icehouse, John, the filter schedule is used when a volume is initially created. It'll take a look at the available Cinder nodes and Cinder storage available, and place that volume accordingly. But it doesn't automatically move that volume to another Cinder node once it's
correct.
Up
yes.
and running.
Yep.
So, and that's
good.
That may change in the future, but at that point, so if you're talking about moving hotspots during production after the volume is created, that is something that needs to be handled by the storage array, or using something like SolidFire where you don't have that issue.
Yep, exactly.
All right.
Good catch.
Are there any remote replication features built into either Cinder or SolidFire?
So the
we'll let John handle that one.
Yeah, this is a good topic. So currently inside of Cinder, there is not, and that is one of the as Ken pointed out in his slide earlier when he said a Cinder volume node goes down, you're done, right? You're toast, and that's because we don't have replication. One of the things that I definitely would like to see, and I've worked on a little bit on and off, is trying to find solutions to actually have in the reference implementation with the commodity storage, is to have a replication solution, so an HA type solution. So hopefully that's something that's coming on the horizon. From the SolidFire side, the SolidFire product itself, and as well as other enterprises, this is kind of what I was alluding to as far as the advantages of going with a third-party back-end device. That most of those devices are going to have built-in HA, things like that. They're going to put you in a much better place anyway. But on top of that, they're going to have things like replication features. There is code that's proposed in Cinder currently to allow you to interface with different replication features that backends might have. That's not released yet, and we're trying to figure out exactly how that fits and where that should live. Because most of that, I think, is going to be an admin function. And the thing is everybody does replication different. Some of us let you do things like replicate just volumes and say, hey, I just want to replicate this group of volumes to this device, and then this group of volumes to that device. Others, you have to replicate entire volume groups or entire devices or pools or whatever it might be. So there's some interesting things there. But the bottom line is the base Cinder implementation needs some work on replication. Back-end devices, most of them have it. It's all different. So.
Yeah, and let me just pick you up very quickly. In our Cinder implementations, in our private cloud and also our public cloud, to be frank, customers are using Cinder typically aren't looking to use Cinder for replication. They're usually running a application like a NoSQL type database that actually does application level replication across the different nodes running using different Cinder values.
Okay. In Fiber Channel, should this be a shared file system? And also, does that mean that the compute nodes also have to be connected to the Fiber Channel infrastructure? Oh, and real quick, before you guys answer that, I apologize. We're at the top of the hour. I just wanted to give everyone a heads up. We'll probably go another 5 or 10 minutes if that's okay with everyone, as long as you have the time. Feel free to stick around. We still have a couple questions to answer, so if it's okay with everyone, we are going to run over just a tad. So just wanted to tell everyone that before you started on your answers.
So trying to recollect the question. So on the Fiber Channel side, in terms of the file system and stuff like that, it depends. So currently today, Cinder, even if you're using Fiber Channel, so to start with, it doesn't allow you to have multiple attachments inside of OpenStack. So technically, even though every compute node, and this is the answer to your other part of the question, every compute node, obviously, yes, would have to be connected to the SAN device, to the Fiber Channel fabric that device is on. Otherwise, the way Cinder works and the way Nova works together, with the way the two pieces work is, Nova says, hey, I want to attach this this volume, this storage object, goes to Cinder, gets the connection information, and makes the connection on the compute node, and then does a pass-through. If you're using KVM and libvirt, it does a pass-through of the device as a virtual device into the instance, into the VM. So you have to have that connection across all the compute nodes. That's the short answer. Since we don't do multi-attach, the file system doesn't matter. That is something that we're probably going to have in Juno, is multi-attach. So that's one of the big caveats and one of the big dangers that people are going to have to keep in mind is if they want to do multi-attach, they better be using a file system that supports it.
Yeah, and just to kind of give a little more detail on that, again, keep in mind that from the perspective of the VM or cloud instance, it is just to them it's a direct attached storage. So it's not actually doesn't see it as a shared volume.
Right.
The only way you could do that would be if you did something like what VMware did, which is they essentially took a Cinder model, but then layered their own cluster file system over that volume. That's what gives them the ability to share out a volume across multiple hypervisor nodes. Currently in Cinder, there isn't a cluster file system that is built into Cinder to allow you to do that.
Okay.
Yeah. So
here's an easier one. What's the maximum Cinder or SolidFire volume size?
Huh.
So on a,
I thought it was.
I think on a commodity storage, it is whatever. It's basically this. I believe the same limit as what LVM will support on a Linux host, because that's essentially what we're doing to create those virtual volumes and share them out in using commodity system. I'm not sure what it is for an enterprise array such as SolidFire.
Yeah, it's interesting. I've never actually thought of that. So inside of OpenStack and inside of Cinder itself, we don't actually have a max volume size. I don't think. It's all going to be based on what the back-end device is actually going to support. And then on the SolidFire side, it depends on which product, which model you're using and stuff like that. I'd have to go and look at the specs. I don't know it off the top of my head. I should, but I don't.
All right. Two interrelated questions, so I'm going to combine them both together. Does Cinder support tiering of storage arrays within one block storage to another block storage? And also, does Cinder support backup of one block storage to another block storage?
So the tiering, interesting. I'm trying to figure out. So keep in mind, like I said, the perspective from Cinder is we're just talking to a back-end device and getting raw block devices. That's really it. It's kind of a simple model. You can do things like we talked about filter scheduler and stuff like that. One of the other things that's really important and almost used everywhere that you have multiple backends is the type scheduler. And what that does is it allows you to say, for example, in your tiering question, if you have multiple backend devices and you want to say device A is tier 1, device B is tier 2, and device C is tier 3, you can create volume types tier 1, 2, 3, and have them mapped to those backends. So then when a user says, hey, I want to create a volume of type tier 1, it will automatically be deployed to device A. It'll go to that right device, that correct device. So I think maybe that's what you're getting at.
Yeah. So keep in mind, again, it's as with the load balancing across the nodes, that is a initial placement process. Cinder will not go back and automatically move things between different tiers of storage. That's again, so at this point, I believe something we're leaving to the enterprise storage array vendor to do. Doesn't mean it might not come into Cinder at a later point.
Yeah, correct.
All right, everyone. We have gone over 5 or 6 minutes here, but there were some more questions there, but I apologize. We do have to kind of cut it at this time. What we could do is certainly if you have additional questions that weren't answered and you certainly want to know more about them, go ahead and reply back to the email, the follow-up emails you will receive, because I believe they will go to me. And I will certainly track down any additional questions that you may have, either about the SolidFire architecture in particular or certainly Cinder in general. And with that, I think the operator, if you don't mind, if you could come back on and close us out.
Ladies and gentlemen, that does conclude the webinar for today. We thank you for your participation and ask that you please disconnect your line.